I do love the talk, but I know you don't love it. All right, so when you're looking at this, did we do this first one yesterday? No, okay, sorry, I'm mixing it in my two classes. We see that the question, specific question is what here? Volume, right? What unit are you probably looking for here? Okay, maybe centimeters cubed, so the volume is a question. It's maybe asking for centimeters cubed, or it could be asking for milliliters or liters. Any of those are acceptable in terms of volume. What do we have? Well, we have this huge kilogram mass, and we have this 0.788 grams per centimeter cubed. How would you start off by solving this problem? Write out what part? So like a proportion?
Yeah.
Okay?
Look at the numbers that we had into the formula.
Okay, so you're going to set up a proportion as a density formula, 0.788 grams per centimeter cubed.
Attention teachers with fourth period planning, just a reminder to report to the PC lab at 1:15. Thank you.
So that's your density, and then your mass, which is going to be on the top, is going to go here. But what do you notice is maybe a question between the two. This one's given to you in grams, and that one's given to you in kilograms. So how are we going to make them agree? How are you going to convert? I don't know. Dimensional analysis, or swooping your decimal for now will eventually morph into dimensional analysis, which is just chemistry math. It's just units, okay? So I'm going to show you how to do that first, actually. So I'm going to put 18,754 kilograms up top over X, which is our volume that we're solving for, right? But you'll notice the grams and kilograms are not agreeing, so I need to make them agree so I can actually use this proportion as I've set it up. So, oops. Let me get some space here. Get some space. Okay, so to use it as a dimensional analysis example, I'm going to start off with my 18,754 kilograms, and I want you to tell me what is the equivalency between kilograms and grams? 1,000 what?
1,000 grams.
Right, 1,000 grams is equal to 1 kilogram. This is called a conversion factor, an equivalency. It's a definition. It can be represented in multiple ways. But this, I'm going to morph into a ratio or a fraction and use to convert. So this is what I think I did one example like this yesterday. So 1 kilogram is what we're interested in, but we actually already have kilograms, so we need to cancel out kilograms to get grams on top, and that's going to be what we'll plug into our proportion up here. So 1 kilogram is going to go on the bottom of this fraction because we need to cancel them, and they have to be opposite of each other in order for units to cancel. That's just the rule. 1,000 grams goes on top, and so if we see the kilograms on top and on bottom, we can then cancel them out, leaving us only with grams. And that's what we want. So we want these two units to agree with each other so we can implement that proportion. So that's going to say we have, oh gosh, we have a big number, 18,754,000 grams. Yes? Okay, we just multiplied by 1,000, that's all we did. But I'm showing you the method in a really easy way so we can start using this for really complicated problems too. These are easy problems because they're just metric conversions. All right, so this is actually what should go up here. Okay, so I'm just taking away the kilograms and putting some extra zeros and grams there. Now you can solve it because now the units agree. So how would you actually solve this? Would you multiply those? You would cross multiply and divide, right? So x times 0.788 is equal to 1 times that, which is just that, right? So we're going to then, I'll kind of show you that process. I need more space. I should have just put these on all separate pages. You can do it, little guy. All right. What is that? So you did, so you're doing that divided by 7.788, great. So I'm going to show you the process of cross multiplication first though. Just in case, you will use this in life in another way, I'm sure. So 0.788x is equal to this cross multiplied, so 1 times big number. And then from there you can definitely see to isolate x, you would just divide by 0.788. And that's what Alicia did, and she got, what again?
23,000.
Okay, centimeters cubed, because we're looking for volume. Okay, and we know that's a big fat lie. We can't record that many decimals or digits, because we're concerned about sig figs all the time now. So, looking at the given information, yeah.
I had the same number, but the decimal is actually after the 9.
Back here. Okay, I'm gonna put it here because I got 2 over 1 there. Let's call that a comma. Yep. Okay. So that's our value. Looking at the given information, how many sig figs should I record in this process?
3.
Why 3?
Because 0.7
Right. So this is my weakest link at 3 sig figs here. This one has 5 sig figs. So if you're comparing the 3 sig figs when, so this needs to be rounded to 3 sig figs, which is going to give us something like, let's see here. These 3 here are the most important ones because when you're rounding, you start from the left and count over. Those 3 have to be recorded. But that 7 is right next to it, or right behind it is a 9. So that 9 is going to influence us to do what? Right, round that up to 2, 3, 8, and then the rest of these things are zeros, right? So I'm not going to write all the zeros out. Can you write this in scientific notation? 2.38 times 10 to the 7th, so 1, 2, 3, 4, 5, 6, 7, thank you, centimeters cubed. Okay, that is our final answer. Whew, that took a lot of work. But basically, I wanted you to see that, density problems can be, I'll leave it right there. Density problems can be really easy, but if their units don't agree, you have to make them agree first and then proceed. So we're really, looking at units in this whole unit and then pretty much forever. So in this cross multiplication process, you don't know how to do that. I can help you with that later. But all we did was took our our kilograms, we converted grams first, and then we plugged it into the density proportion. And then from there, we used our sig fig knowledge to solve. Okay, let's do number 3. No, lie. Let's do number 4. 4 is the one that looks like it's a big word problem, but it's not. Okay, I want you to start by writing down your given information. You might need a separate sheet of paper for this process, just because there's not much space on that paper. So start by writing down your given for number 4. If you were not here yesterday, there's a video up on sig figs. It's on YouTube. You can subscribe to my YouTube channel, or not, and just always look on my website for links. That one video was like 600 views. Just saying. So writing down your givens and just numbers of their units that are important. After reading this, what are the important things here? Jot them out. So 36,763 liters of helium, but where was that found? In the jar, right? And I'm just going to label that jar because you'll see that it's asking for total volume between the whole, every part of the float, so that might be important. What else? Body size, right? So The jar is 1/10 of the body. So how big is the body?
10 times bigger.
So how do I do 10 times bigger than that? Multiply by 10. So what is that total volume? I mean, what is the volume of the body?
367,000.
So move the decimal over one good. So 367 and then 630 liters of helium in the body, right? That's a huge Macy's Day Parade float. 2000. Where were you in 2000? Are you alive? You guys alive in 2000? Okay. I was in 6th grade, just saying. I remember. I had to move to this new middle school. My mom didn't tell us, but we had to wear uniforms. I was devastated. Okay, as an 11-year-old. Okay, so here's our liter and liter, jar and honey, jar and body. And so we just want to get the total volume. We're just going to add, right? So that part's pretty simple. That is 404,393 liters total. Okay, so we got our first answer, right? Now we're going to use that information to go a little further. If the density of the helium is, small number here, 0.000178 grams per centimeter cubed, that's our density. How are we going to get to the mass of helium? I want you to try to model what we did on our last example. What are some things you're noticing first? Units are different, right? So I need to convert liters to something more usable. Centimeters cubed is going to keep popping up, right? But if I'm in liters, I don't want to use centimeters cubed. What do I want to use? Say again? Remember what 1 centimeter cubed is equal to? 1 milliliter. Fun fact you should know. I'm going to keep it up here for a while. 1 centimeter cubed is equal to 1 milliliter. If you want to use milliliters all the time, I'm cool with that, but just be familiar that they are equivalent, and I like using milliliters, so I'm going to rewrite that in a different way. All right, so I need to take my liters to milliliters first, so I can implement this density part in a second. So, again, milliliters and liters, what is the conversion? 1,000, right? 1,000 what?
1,000 liters to 1 liter.
Right, there's 1,000 little bitty milliliters, so 1,000 little bitty milliliters in 1 big liter. 1 big liter. And I wrote it this way, why? Why not flipped?
So we're trying to convert to liters.
Yeah, your liters here and here have to cancel, and I have to stick with milliliters because that's how I'm going to plug density in eventually, right? So this states 0.000178 grams over 1 milliliter. So do I want to write the density? So I'm converting to mass is what I'm getting ready to do, okay? Do I want to write the density as is, as a fraction, or do I want to flip it for the 1 milliliter on top? If I put the milliliter on top, milliliters and milliliters are right next to each other. So I need to leave it like this because I need milliliters to be on the bottom of my next part of my process because I need the milliliters here to cancel and leave me with grams, which is easy enough to get to kilograms with, right? So the density is going to pop right here, and I'm going to go ahead and put the 1 milliliter on bottom to show you that you should always have your crossways units here, and then 0.00178 grams of helium on top. So we're almost to total mass, right? We're almost to the kilograms it's asked for. So I'm actually doing a 4-step process in one big slew here, okay? So the milliliters here canceled with the milliliters here, and I did that on purpose, right? Now I've got grams. Thinking back your metric, what's the equivalency between grams and kilograms? Heard it? 1,000 again, right? 1 kilogram is huge. How many little bitty grams are in 1 kilogram? 1,000, right? And that's the equivalency that we're then going to input right here. This is dimensional analysis. This is something we're going to go into a good depth tomorrow in, and that's problem set 3B. But I'm giving you some exposure so it starts to sink in a little more. Yeah.
You said equation for density is divided by volume. How would you represent the volume to the top on the left side?
Over here. So this is information that's not really related to density at all. This was just me seeing that I had 2 parts of the float and I added it up. But I'm using the volume of the float and then the relationship between volume and mass, which is density. I'm using that relationship to convert my volume to mass, which I'm not quite to yet, but I'm almost there. So this is actually, this is density, right? This is density, but density is our only crossover between mass and volume. There's nothing else that it connects it to. So that allows me to use it in multiple ways in converting. And so that's why I'm using density to convert from volume to mass. So it's more the concept of how to convert. So density is just a tool to use. Okay, so I'm in grams. Actually, let's just go ahead and figure out what grams is right now. Calculate. Everybody should have a calculator. If you don't, there's a tool box over here. You guys can grab one.
And if you guys ever need them, grab them, but make sure you put them back on the way out so that you don't have any plastic meals.
You might, well, no, so you might be in your head, but you won't. Okay, so what do we have here? How many grams? You're going to be multiplying 404,393 times 1,000 over 1, and that 1 doesn't do anything for a number because dividing by 1 is nothing, right? And then times by 0.00178. Shout it out when you get it. It's a big number. Yes, ma'am.
719.
You say 981?
Yeah. 0.951.
Okay, and that's in grams. All right, so we know that number is not our final answer. If I know that 1 kilogram is equal to 1,000 grams, as I have at the top of the board here, I'm going to then actually multiply the grams to kilograms now, or you can probably think about the swooping of decimals that you've probably done in the past. 1 kilogram is going to have 1,000 grams in it. And I'm writing it this way because my grams and grams need to be kind of counter to each other. Yes, sir.
Didn't you have these canceled out to 1,000?
I could have, because that's what, well, because I'm going to be showing that here. If I've written it up here, you can simplify your steps all in one. But that's good that you're seeing that now. So I'm just showing the whole process, baby steps, and then we're going to start doing that. Okay. So this is us dividing by 1,000, which he's right. We could have, in one big step, canceled, but I'm going to move the decimal back 3 spaces to represent that. So 71.98195, blah, 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 kilograms. How many sig figs should this answer have? Why are you saying 3?
Because 0.00178 minus 3.
Right, so the density there has 3 sig figs in it, so this answer in the end should be recorded to 3, which is what when you round it?
72.0.
72.0, good. Because this, you want to do 71.9, but the 8 is going to round the 9 up, so we have to round everything up. Okay, that's again, word problem, density, some other stuff, conversions, and then we're always thinking about sig figs. So I'm just trying to model a couple different types of prompts for you guys before we jump into our lab. Okay, let me go ahead and talk about problem set 3A. Any glaring questions, things that you just had no idea how to do, I'll answer them now. Don't be afraid to ask questions, because somebody else needs to ask. I guarantee you has a question, and they're not going to ask it, so I'd prefer you to ask that first. Yep. Always, yes. So what did you get for your answer? So, but before you rounded, you had 480. 1, 2, centimeters cubed. This is number 7, by the way. That's what I think most people probably got. You with me, AJ? That needs to be rounded to sig figs, or appropriate sig figs. In this question, we had a limiting of what? 2 sig figs. So that needs to be rounded to what? 480, right? Because you don't just put 48. 48 is not even 480, right? It has to be a similar number, but the 3 has to be recorded as a 0, so we're rounding down basically, so that we can have a recorded number of 2 sig figs at the end. Good question. Another question, guys? Okay, speak out for which piece. Anything? All right, go ahead and pass up PS3A to the front of your desk areas, and I'll come around across the rows and pick them up. Pull out a piece of paper for our lab. and I'll explain to you a little bit more, and then we're going to jump back in the lab. So make sure it says your name on it and just 3A, so I'm going to give it back to you. Just pass it to the front. Alright, so pull out a piece of paper for your lab. Anybody else? Anybody else there? One more. All right, so thank you. For our lab, this is called an inquiry lab, meaning I'm not going to give you step 1, step 2, step 3, step 4. You're going to have to kind of dive in and solve your problem based off what I'm asking you to do. So I'm giving you 8 items, some miscellaneous objects, right? A little plastic frog, a brass brad, some cubes, so basically saying irregular shaped objects and then regularly shaped objects. Like prisms are regularly shaped. How do you find the volume of a prism? Length times width times height. How do you find the volume of an irregularly shaped object? Like a rock.
Oh, you did
The water thing, what's that called?
Water.
So you have a certain amount of water, you put your thing in, the water rises. It's called volume displacement, or water displacement, okay? So those are your 2 methods of solving for volume, and the other ones are mass, so we're going to be using a scale. All right, so I'll give you 8 objects, and you have to find their masses, volumes, and therefore their densities from that via calculation. And I want you to order them from least to most dense, and then take a picture of it and send it to me on email, okay? One person needs to do that. After you do that, you're then going to start to work with graphing some. So you're going to graph your mass versus volume, and I have an example down here. I'll help you with that towards the end of the lab, but you'll just be having one person graph collectively with your group's help, mass versus volume of yours, and then from there you're going to extrapolate, and you're actually going to have your densities represented as slope of your line, okay? But before you do that, you have to get your densities, okay? So other than that, the lab station is yours. You have graduate cylinders, you've got all kinds of equipment. I want to give you a quick preview to like where you would find your labs in your lab notebook, and then I'll leave you in let's work, okay? Last statement. Every lab will have a purpose statement, so just read through the intro and then come up with a one sentence statement about what the purpose of your lab is. So it's a good review for whenever you're trying to figure out what the heck do we do in the lab, okay? So go back to your lab stations that you had with your safety procedures. My couple of people that I need to say are Nana, Morgan, wait a second, and Andrew we talked to. Underneath your lab station, there is a notebook that's colorful. It's probably like pink or yellow or orange. Look under your lab station and find the lab notebook. It's in the very bottom. Very bottom. Thank you. Alright, it's probably the 5th or 6th page back. It says density of solid dash increase. Density of solid increase. Yep. Density of solid increase. It's not very sharp in this lab. So this is where you can find your lab. In every single case, I will just tell you basically the title is and you gotta find it. All the equipment is there for you. Ask me questions as you need to. Please make sure you're reporting to stitches on everything, okay? Everybody has to have pretty much the same thing on their computer in terms of calculations, showing and etc. Okay, jump on it. Don't forget about the purpose statement. Don't forget about the purpose statement. Thank you. So since you can't go to the lab, just remember to
Make sure you show her today. So under on page 96. This will be your big assignment because I need you to have. Start here. Keep going. Chapter 12.